Today we're going to talk about API Spec First Development, because seamless cross-team development is possible. Now, you might be wondering, why the should I listen to this dude? Well, basically because I have real-life experience using this, many years of experience implementing this framework, and because this is going to be evidently obvious. You're going to resonate with a lot of the ideas that I'm going to talk about here, even if you didn't directly apply API Spec First Development. This is not going to focus on the different technologies or the tools that you can use, because those are going to age pretty bad. This is more to get like an overall mental model of how we can use this in our day-to-day programming life. And finally, you can trust me all you want, but you can verify this yourself, implementing the smaller changes in your own process, organization, or company, and seeing the results for yourself. You might wonder, what API specification-driven development? Well, at the very basic idea, it's just this. Think about what the system should do, establish a contract, basically write it down somewhere, ask for feedback from the different stakeholders, and then you can iterate over this, address the requests, or if everything looks good, you can start building. But the basic idea is that we have to iterate over this part, because it's much easier to iterate over a contract than to iterate over code that's already in production. Now you might be wondering, why API specification first? Why start with the API or the contract? Basically, to avoid this. How many times have we started working on a project? You can imagine this being, for example, the backend team and this being the front-end team, and stuff like that happens. The whole project looks almost finished or complete, but there's a very big mismatch in requirements from both of the sides. Now, I talk all the time about a contract and API specification, but what is a contract? Now, I could explain to yourself the definition, but I'm going to ask for a professional opinion from a lawyer so you can see what it really means in the legal context.
But I ask you, what is a contract? Webster's defines it as an agreement under the law which is unbreakable. Which is unbreakable. Excuse me, I must use the restroom.
Okay, so now, all jokes aside, this definition really resonates with us, because when we create an API specification, we're basically creating a contract. We have to comply with it. We cannot break this contract. Once we agreed on it and everything looks good, unless there's a problem with it or an error, we have to continue supporting it from as long as we can, for the whole life cycle of our product. And now this framework is not going to be useful for very small teams, for people working on individual projects. This framework is very useful for teams, for big teams, because writing code yourself, when you have a lot of experience, is very easy. But the problem always comes with managing people. Ensuring collaboration is fluid and people don't blame each other for the failures on the specifications. Now, you might be thinking that you're working with API specification first development because, for example, you use Fast API that automatically generates the Swagger specification, or you use Nest.js with the Swagger plugin. But really, you're doing this. Backend driven development. The backend team develops, then they deliver, then the front-end team starts developing, they may find some issues, and report them and refine. This part of the process is very slow, and once everything is settled, the front-end team can deliver. The main problem with this is that throughout the life cycle, for this very big portion of the time, the front-end team is blocked. Now, I put here back-end and front-end, just an example, but in reality, when you work on large organizations with many different teams, this can be both backend teams from different microservices. This is what we mean when we say API spec-driven development. This is an example where we have two teams, the backend and the frontend. They establish a contract, they iterate over the contract, and then when it's all good, both teams can develop in parallel. This is very important because the refinement goes over this stage. And remember, iterating over a contract, for example, an API specification like Swagger, OpenAPI, or async API is much faster than iterating over code. We can see how API specification first development aligns with project management. Here we have an issue. This can be Jira, linear. We have a user story that this is a functional issue. This can be done by the PM, the PO, the STO, and then we can create sub-issues with the technical implementation. Like here, API, create the contract. This is more aligned with the engineers, the STO, the tech leads, the front end, the back end, any kind of engineer. And then, of course, this issue blocks the implementation, but this should be fast to create. And once this is done, both teams can work in parallel. This is another example. This could be some repositories a project uses. This example is very basic, just some monoliths, a backend repository, front-end repository, and a third one, which is kind of new, is the API specification repository. This one is where both teams have the responsibility of creating pull requests, reviewing it, deciding what the contract should look like. Once the contract is defined, the word is final, and the backend and the front end should develop new issues to address the contract. Now, when we say backend teams and front end teams, we do not mean a very big separation. We do not mean that people have to only be part of one team. We can have people working on both teams if they are full stack engineers. But what we have to understand is that when we talk about responsibility, we really mean it. If the backend team or the front-end team commit to a contract, they have to go through it. There's no excuse. What we also want to do with API specification first development is to avoid excuses. Once a contract is committed, you cannot go and say, oh no, but that's bad. It shouldn't have been that way. Okay, if it shouldn't have been that way, you should have said so. And if it's already committed, you can create a new specification to address those problems. Okay, so now we're going to talk about Spec First microservices, because this framework really shines on organizations with multiple different teams. This is an example repository map. Here we have many different teams. These teams communicate with each other. They have a common objective on some part. This can be synchronous communication via HTTP or asynchronous via a message bus. And now we see that, of course, the responsibility of building the service itself is part of each team, but they are all stakeholders in the API specification, the consumers and the producers. Of course, by different degrees and different lengths, and each team should address the part they are going to use mostly, but they are all stakeholders of the contract. They must always uphold the contracts they participate in. And now going back to this diagram that we made earlier, we see that Spec First does not necessarily mean backend and front-end teams. We can have n different teams, and once they establish a contract, they can all work independently. So API Spec First development enables all teams to work in parallel. Now we're going to talk about tooling. Tooling is the part of the video that's going to age worse because new tools are going to come out, and some of the tools I'm going to talk about are going to become obsolete. Spec First development is a mental framework. You can implement all the different tools you want, but the most important thing is the mental model. We're going to talk about the API specification repository itself. You understand the concept of having, for example, a backend repository, a front-end repository. And with the API Spec First framework, we're most likely going to add a new repository for each project, which is the API specification repository. This repository is going to handle many different, probably JSON or YAML files, depending on the tool you're going to use. The most popular ones are Swagger, OpenAPI, Async API. We're going to have many different JSON files connecting with each other. This is going to be basically like an index, a specification for our API. And then usually what we do is we take all these different files that are usually separated in folders, acting as modules or bounded contexts. And then we're going to take all these different files and create one big file that has everything inside it, which is usually called the bundle. And with this bundle, we can do many different things like generating UI, code, and documentation. Because the nature of repositories, we're going to introduce a lot of changes on our API specification over time, and we have to make sure that we do not break user space. This is a famous email that Linus Torvalds, the creator of Linux, sent because one of the developers broke user space. We cannot start introducing breaking changes to clients that have already committed to our contract. That way we need to use semantic versioning to handle the different changes inside our API repository when we declare major changes, which break the specification, minor changes, which usually add new features, and patch, which usually address non-functional changes. And we have to make sure that we do not break contracts. Most backend frameworks, most frontends, they allow semantic versioning. You can subscribe to multiple different API endpoints, so this should not be a problem. We have no excuse in breaking people that are already using our product, especially when we're in production. Now, for the backend, we have many different kinds of tools. And I think that the most important ones are the ones where you take the bundled API specification, you give it to the framework, and they validate all the incoming requests. So if a request does not match the specification, it is blocked. If we're talking about HTTP, it returns a 400 error. It handles routing. It automatically routes specification endpoint to their correct handler, and they also check authentication. And also there are different tools like Swagger or CLA where you can give it a bundled API specification and it can generate Python or JavaScript code. This is not a validation. This is actual code with interfaces, models, and controllers. And on the front end, you're going to have also many tools available. The most important ones for me are the ones that generate front-end API requests and types. They're going to save you a lot of time. You're going to give it a bundled API specification, and it's going to output TypeScript code ready to use, so you don't have to go around and checking the different endpoints created in different models. It's going to do it automatically for yourself. And also another useful feature is that, for example, you can create mock-end backend servers that you can use for testing. You can add continuous integration and delivery to your API specification repository with many different things. For example, on the integration side of it, you can add linters, formatters, validation to make sure that your API specification works as expected. If you use JSON API specification, you can check that the JSONs are valid. You can check that they are formatted in a particular way. And on the delivery side of it, you can generate the code automatically on the pipelines. You can release it, you can create SDKs for the backend and the frontend, and you can notify all the different stakeholders that a new release is out. This is a very common Git flow that you can use. You can basically create PRs in the API specification repository that everyone should check, all the different stakeholders check and approve, and then with the continuous integration and delivery flow that we talk about, we can basically release this API specification to the different teams. They can be backend or frontend teams. And then each team is responsible for the implementation on their service. AI aligns pretty well with Spec First Development because LLMs excel at processing and outputting structured data. Now, because LLMs excel at using structured data, we can take our existing code in the name of service code or API specification code. We can give project information with Jira or linear integrations, and we can feed the LLM context so it can output a new API specification. And with that API specification, we can create JavaScript, Python, whatever you want type of code. And this is iterative, this is recursive. We can use the generated outputs for the LLMs to address new functionalities. Now that we're getting to the end of the presentation, we have to address the hype. There are many risks involved with going full-on API specification-driven development. Now, the good side of it, we have clear contracts, we unblock teams with parallel development, we can create better automation, we have clear governance. We know which teams are responsible of what, and we have consistency across the different teams. And overall, in my opinion, this is a much better experience for developers. But we have to talk about the bad side. It costs money. We have to make an upfront investment in infrastructure and man hours, which translates to money. There's a very steep learning curve. It's not easy to work with API Spec First Development at first when you have not used it. There's a lot of bureaucracy. Simple functionality may take longer because you have to address the contract, then approve it, then create the code. There's also tooling limitations. The ecosystem is pretty good. People are working on this very hard. There are many open source projects that you can check out, but of course, some things need to be polished a bit more. In my opinion, API Spec First Development excels when there are multiple teams, organizations grow, they are large, there's a lot of microservices, and there's ownership problems. Teams start giving excuses to why the code is not delivered, and they start throwing blame at each other. This is very good to address that. When it's not really useful, or maybe it will add more overhead than benefits, is when you have very quick MVPs, few people, early stage startups where speed is much more important than everything we talked about. Now, to close this presentation, if you're very hyped up, I want you to put your foot on the brakes and slow down. Implementing big changes is hard. People don't react well to changes. You first need to make your teammates understand why API Spec First Development is good. Then you have to make sure they agree with the idea of plan first, work later. And only after that, you can go around and start implementing one tool at a time. If you try to implement everything at once and be a tyrant about it, you'll most likely fail. And people are going to hate API Spec First Development in your organization. Thanks a lot for reaching to the end of the video. Please check out my site. I like to generate content like this and discuss software engineering topics. You can also scan the QR code here and go directly to my page.